Once you're done, please send it to me on WhatsApp. You're free to look in the notebook, okay? We have done similar type of questions also. Please try to find the patterns and then send the answer in my WhatsApp. Try to make ethoxybenzene properly, Josefa. You have not made it correctly. That's not the structure of ethoxybenzene. Two more minutes, guys. 2 more minutes. Please send the answers. Guys, please send the answers. Muzafa, you must know how to draw ethoxybenzene. Okay, fine. So let us see. Now, both of these questions we have done in the last class, okay? So if you look here, this is 2-methyl methoxy propane. And here we have done a simple example in which we have done alkoxybenzenes. Okay, alkoxybenzene and ethoxybenzene is one of the alkoxybenzenes. Now let us write the answers here. For ethoxybenzene, you first of all draw the product, whatever they are asking. Walaikum Assalam, Kenza, how are you? Okay, Zan is also here. Hello, Zan. Hi, how are you? Kenza, am I audible? Hello.
Yes, sir.
Yes. Okay, fine. What happened? Why are you late?
I was trying to join, but I guess there's some issue.
Okay, fine. Hello. Assalamu alaikum, Zan. Am I audible? Hello, Zan. No, I can't hear you, Zan. Okay. Can you tell me which school are you from, Zan? Which school are you from? New Middle East International School. Okay, fine. So I think in your school. Okay, Josefa is your classmate. Okay, okay, fine, fine. So electrochemistry. Okay, fine. Alcohol phenol ethers and then electrochemistry. Okay. Zan, I will talk to you like after this class ends. Okay, you're also a bit late, so I will talk to you after this class. Try to understand whatever is being taught here. Then I will talk to you. Okay, chaliye. So first of all, we have ethoxybenzene. They are asking me name the reagents and write the chemical equations for the preparation of following compounds by Williamson ether synthesis. Right, Williamson ether synthesis. Now this Williamson ether synthesis, it needs two things. It needs RONA, alkoxide ion, and it needs R-Br. This is something that we have learned already. Williamson ether synthesis is done with alkoxide and haloalkane. Now, when I look at this ethoxybenzene here, and what happens actually, let me also write the reaction for this. RO, this RO is coming from the alkoxide, and then the R dash is coming from the haloalkane. Okay, so we form an ether, and the alkyl group of one ether, the alkyl group in the ether, it is coming from one of the alkyl group is coming from the alkoxide ion, and the other alkyl group is coming from the haloalkane. Now, that is something that you have to always look whenever you are drawing an ether and you want to draw it, you want to make it from Williamson ether synthesis. So we have benzene and it is connected to oxygen and two carbon atoms. So this part here, it is ethoxy, and this part is here is the benzene, right? Okay, so ethoxybenzene. You have here ethoxybenzene. Now, when I look at these two things, one of them should come from haloalkane and the other should come from alkoxide ion, And as we have learned in the last lecture, that we can make this only through phenoxide ion plus CH3, CH2Br. Because if we take the other way around, if I take a haloarine, then this haloarine cannot break, then this reaction cannot break this particular bond. Okay, so this bond cannot be broken, and that is why it cannot convert itself into ether. So this cannot happen. That is why the only chance we have is with phenoxide ion and haloalkane. If I look at the next one, that is 2-methyl 2-methoxypropane. So we have prop, so 1, 2, 3 carbon atoms, and then we have in the second carbon atom a methyl group. So I'm putting here a CH3 group, and then I also have a methoxy group here. So OCH3 group. Now this also we have already done. So we have here two fragments. We have the CH3, and then we have this rest of the fragment, this alkyl group. So the bigger alkyl group that is should be coming from ONA, and we should have CH3Br like this. Since Williamson ether synthesis is an SN2 reaction, that means the nucleophile should attack on the primary haloalkane. Our haloalkane should be 1 degree. That is why we have these reactions. Okay. If you don't see, we have done this one also here. Same question, last class. Okay, same question last class. We have also written many points here. Furthermore, usage of 2 degree and due to steric hindrance, alkoxide ion could not attack the CX bond, rather it attacks on the base and it attacks as a base and forms alkene. And if I take the other way around. Similarly, I have said about haloarenes and alkoxide cannot be used. Alkoxybenzene can be prepared by treatment of phenoxide ion with haloalkene. Okay, so please start revising, guys. I think you guys do not revise. Okay. Now, the preparation has been done. Sahal has sent the answer. सर अभी तो आप तो अभी भेज रहे हैं. अच्छा हाँ, पहला वाला ठीक है आपका, लेकिन ONA का बॉन्ड बनाइए ना. आपने बॉन्ड ऐसे बना दिया है इसको. You have made something like this. That's not right. You should make it this. ONA. Okay.
Okay, sir.
Now we are going to look at the chemical properties of. We are going to look at the chemical properties of ethers.
So can you scroll up?
By the way, I hope you remember this arrow. This arrow is retrosynthesis arrow. That means this molecule can be made by this and this particular reagents. Done, everyone? Yes or no? Please tell me. Right, next. Achha, first of all, let us look at physical properties. With the first point, ethers are slightly polar. Okay, so they don't have anything else. They are just polar molecules, slightly polar also, not very much polar, slightly polar. Then right next, ethers have, please write this with me, lower boiling point than alcohol, as alcohols can form hydrogen bond, but ethers cannot. Ethers can't. Okay. Right, next. Boiling point of ethers is slightly higher than that of hydrocarbons. Hydrocarbons of comparable molar mass. I hope both the things are self-explanatory. Right, next point regarding the solubility. Now, when we look at solubility, if I look at ether is R oxygen, and then you have another R group like this. Okay, so this is an ether. We have lone pair electrons like this. And if check the solubility inside water, so inside water you may see that you'll have hydrogen, which has oxygen bonded to it, and then it has another hydrogen. Now, this hydrogen here, it is what? Delta positive, because it is connected to oxygen atom, which is very electronegative. Now, this hydrogen can form a hydrogen bond with this oxygen atom, right? And see, ethers with themselves, they will not form hydrogen bond, but they can form hydrogen bond with the hydrogen of water, And that is why these are soluble in water. You write next. Ethers are soluble in water. Okay, ethers are soluble in water as the ethereal oxygen. Ethereal oxygen means the oxygen which is making this ether, right? This oxygen, ethereal oxygen, can form hydrogen bonds with hydrogen of water. Okay, right, next. Similar to alcohols, increase in number of carbons in alkyl group, number of carbons in alkyl group. What will it will do? It will decrease the solubility, decreases the solubility of ethers in water. Write this down, guys. Then everyone is going to tell me.
Yes, sir.
Okay. Kinsa, like your school is International Indian School, but which International Indian School, Kinsa? Which city?
The mom.
Dammam. So you are doing electrochemistry, right?
Yes, sir.
And electrochemistry will be asked in that October test, right?
Yes, sir.
Okay. So after this chapter, we'll do electrochemistry only. I think everyone is having electrochemistry, even okay, not Ashwarya, but right? Ashwarya Kaningora was electrochemistry. Okay, I'll see. No, please write chemical properties. See, the only question that can be asked is, I'm also writing the question, you can write the answer later on. The question they will ask you. Last point is left. Achha. We'll ask boiling point of ethers is much lower than that of alcohols. So here you can just write the answer. Ethers do not form hydrogen bond, but alcohols form hydrogen bond. That's the reason. Okay. Write it fast, guys. And then you will write the chemical properties. Done, everyone is going to please tell me. लिख लिया आपने? देखिए लक्ष्य तो आपने right here chemical properties. Number 1, cleavage of CO bond. Okay, now right here, treatment of ethers with HX leads to formation of alcohol and alkyl halide and alkyl halide. Okay, so see here you have R, O, some R dash. Okay, now let me write it first of all for symmetrical ethers only, R, O, R. Okay, so here what is going to happen if I am reacting any HX, and most importantly and most prominently it is going to be HI. But even if you have HX, so this oxygen will join to hydrogen and this R will get the halogen atom and these two bonds will break. So now you can see very easily we are having ROH plus RX. Okay, so you can write here, if you have symmetrical ethers, then the products are going to be very easy. For example, if you have CS3O, CS3, and you're having HI, then CS3OH will be formed, right? And CS3I will be formed. In the form of HI. So this is again same thing. Both of them are same symmetrical ether. So one of them will get 1 2 carbon atom OH and 1 and 2 carbon atoms iodine. Write the product for this one. Also write the product for this one. You have to send the answers on my WhatsApp, okay? So Zan, you can also try this. You just try to identify the pattern and then you send it to this number. Okay, Zan. You try to identify the pattern and then send it to this number. Others, all of you understood? Yes or no? Please tell me. Adriel, Ashwarya, Fahad, Huzaifa, Kinza, Sahel. Yes or no? You understood how to make the product?
Sir, understood.
Yes. Ashwarya, Adriel, tell me.
Yes, sir.
Yes. Okay. Kinza, what about you?
Yes, sir.
Yes. Okay. Fine.
So this is the last topic, right, of this chapter?
No, last topic, correct. Chemical properties ना last topic. तो next class से आपका नया chapter. I have received from Sahel. Okay, Sahel. नहीं, सेकंड वाला हाँ चलिए ठीक है, करेक्ट है सर, वेरी गुड वेरी गुड. Okay, Adriel, I have received yours. Correct, very good. Okay, fine, but try to make the cyclopentanes a bit more properly, na? जो iodine वाला है आपका last, I mean it's kind of looking like a square only. I can't see that there are 5 vertices there. Okay, but it's fine, no problem. Okay, थोड़ा सा उसको बस ठीक कर लीजिए, nothing else. Okay, Zan, I've received yours also. Yes, Zan, very good, correct. These are correct. Kinza, yes, Kinza, very good. Aishwarya, I have not received yours. And Rishan. Rishan, आप हैं या नहीं है? While revising for aspects and all the way identifying the knowledge person or myself. Okay. Sahel, you have to go back to the
जी सर,
11th standard lectures. Do you have the 11th standard lectures?
चेक करना पड़ेगा सर.
चेक करना पड़ेगा, ठीक है.
So I don't have it, sir, for this
You don't have it?
topic. No, I don't
ठीक है,
have
I'm
it.
giving you. Aishwarya, I'm rewaiting. Okay, Aishwarya got disconnected. Okay. So this is going to be OH plus here I will have I. No. I mean यहाँ भी आप I लिख सकते हैं. Both are same only. I hope you can see that. Iodine. Okay, let us see what is going to happen if we have unsymmetrical. Slide B part. Unsymmetrical ether. So when we have unsymmetrical ether, if we have 1 degree, for example, you have something like this. Let us say you have 2 carbon atoms here, oxygen, and then you have here CH3. Okay. So in that case, what is going to happen? In that case, what is going to happen? The HI, this iodine will attack on the CH3. Okay. And if iodine is attacking on the CH3, I will get CH3I plus OH like this. So this is an SN2 reaction. Okay, this is an SN2. If 1 degree ka bhi aapko dete hain. If you have something like this, let us say have here 2 degree, and then there is CH3. So here also what is going to happen? HI will attack on the less substituted one. Here also it is happening via SN2. So we are getting CH3I plus we are getting a 2 degree alcohol. But if I have a 3 degrees, something of this kind, oxygen and then CH3. Now let me show you what happens actually. We have H plus first of all. This H plus gets attacked by the oxygen's lone pair electron. And we get oxygen, and then CH3. And then hydrogen here with a positive charge. Now what can happen? Two things can happen. The iodine negative, the iodine negative, it can either attack on this carbon atom or it can on this carbon atom, right? But what happens actually is that iodine does not get any chance to attack. First, this whole molecule, it breaks down and we get directly, first of all, CH3OH plus 1, 2, 3, 4 carbon atoms. So you'll have something like this and a positive charge. This is a 3-degree carbocation, right? This is quite stable carbocation, and that is why further reaction happens with iodine. And the iodine attacks onto this carbon atom, and it makes a tertiary haloalkane. 1 to 3 carbon atoms, and then you'll have an iodine here. Okay. So only in 3-degree, if you have a 3-degree alkyl group in the ether, then you're going to make this product. You write here as a note. Since 3-degree carbocation is very stable. 3-degree carbocation is very stable. The protonated ether forms 3-degree carbocation and alcohol. Further, I negative attacks the 3-degree carbocation forming alkyl halide. Okay, so this reaction is happening via SN1, formation of carbocation and then the attack of nucleophile. Okay, so see, this type of question will be asked. ये देखिए, अभी जो हमने पढ़ाया ना, so here what they are asking, you have the same thing, CH3 carbon atom with 3 CH3 groups. And OCH3. Now, when I'm reacting this with HI, they're asking that it gives CH3OH and it gives 3-degree iodoalkane, right? As not as main product and we do not get OH plus CH3I, right? This is not happening. Why is that? So you will write this very much point, okay? This 1 point only. And then you will form, and then you will show this particular mechanism here. So those two things are very important. You have to show both of them. You'll write this one line, since 3-degree carbocation is very stable and the protonated ether forms 3-degree carbocation and alcohol. Further, iodine negative attacks on the 3-degree carbocation forming alkyl halide, and then you will show this particular whole mechanism here. Okay, so both are important. You have to write both the things there. Done all of you? Someone please tell me. You don't have to write this question, by the way. Okay, I'm just showing you that this type of question will come. लिखिए आप लोगों ने? Yes or no? Please tell me. Yes, what happened? I have real Fahad, Huzaifa, Kinza, Sahel. Done?
Just a second, sir.
Just a second. हाँ तो बोलिए ना, नहीं हुआ है.
Done, sir.
Practice and please revise daily. बार बार आप लोग को बोलेंगे, लेकिन आप लोग एकदम ही लगता है कि रिवाइज कर रहे हैं. You can't do the last class questions also. Right, next, if we have alkoxybenzene. So alkoxybenzene, it will have something like this. OR. Okay. Now let us see. I mean, either I can make something like this. Either will make phenol. If I react this with HI, and I will be getting RI. Or what can happen? The other way around. I will get iodine here. Plus I will get ROH. Okay, so if I am breaking this bond, this red bond, then this product is getting formed. Sorry, blue bond. No, if I'm breaking this blue bond. Okay, so let me break this blue bond. So this product is formed. If I'm going to break this red bond, then this product is going to be formed. Now you tell me, guys, which of them is easier to break, the blue one or the red one? Write in chat, please, the answer. Which is easier to break? This blue one will be easier to break, or this red one will be easier to break? Red one. Yes, correct, Huzaifa. Correct, Sahel. Why? Can you tell me, Sahel, Huzaifa? Why the red one? And why not the blue one? Tell me that. I think that will be a better answer. Alcohol group is present in the blue. No, once again, thoda sa aur theek se. What will happen? Why is this bond strong? You're saying this bond is strong. तो यहाँ पे भी तो कार्बन ऑक्सीजन बॉन्ड है ना. ये R क्या है? R भी तो आपके पास कार्बन एटम्स ही है ना. You can have the CH3 here. Kinza, what do you think? Kinza, tell me, which is easier to break, red or blue? Yes, Kinza? Can't
Red.
hear you. Red, why red? Why not blue? Tell me that. Why not blue?
Because you have benzene.
So, what happens with benzene? See, whenever you will have oxygen, this will show resonance now, and this will get partial double bond character. This CO bond will get, the blue CO bond, it gets partial double bond character due to resonance. Do you guys remember it now?
Yes, sir.
ये चीज आप लोग को अब दिखनी चाहिए, ठीक है. जैसे ही हमने बनाया, आप इसको डबल बॉन्ड ही कंसिडर कीजिएगा, ठीक है. दिस बॉन्ड हियर, because it has lone pair electrons, it's partial double bond. Okay, and that is why what is going to happen? This red bond is going to break, and these products will not be formed. Okay, this reaction will not happen. This reaction will happen. Okay, this reaction is going to happen. Okay, so this bond is going to break. Okay, you will write here as a note. You will write in the downside. Due to partial double bond, character of, that is one of the reason, partial double bond character. Due to partial double bond character of CO bond between benzene and oxygen it is difficult to break. Okay, also another reason is iodine negative will prefer to attack alkyl group as it is less hindered. It won't attack benzene ring as it would lead to electronic repulsion, right? Because iodine negative is also electron rich, benzene is also electron rich. So write this down. दो टॉपिक प्लीज आपको पढ़ के जाइएगा whenever you are going, like whenever you have test now in ethers you have to remember to learn and read WES, Williamson ether synthesis, and the reaction with HI. Even if you are done one time revision, you will again revise these two topics because these are the two most famous topics and the CBSE's favorite topic for asking questions. Okay, Williamson ether synthesis and the reaction with HI. Most of the question has been asked from these topics only. Done everyone? Yes or no? Please tell me. लिख रहे हैं क्या
No,
अभी
sir.
तक?
Yes, sir.
लिखिए, लिखिए।
2 minutes, sir.
Yes, yes, fine, fine. लिखिए, आराम से लिखिए। And also one more thing I am trying from the very first, I'm saying this from the very first day, is that you should read the complete thing and then write the complete thing with your understanding. Okay. So you should not write line by line also, like due to partial double bond, due to partial double bond. Then you're looking at the same due to partial double bond, character of CO bond between character of CO bond. No, not like that. You read it once at all. Like due to partial double bond, character of CO bond between benzene and oxygen, it is difficult to break. So you can visualize also, like, okay, fine, the benzene and oxygen are having CO bond and that bond has partial double bond character, and then you can write. Okay, so that will also make your writing faster.
हो
If
गया
you
सर.
write line by line, then it is going to be a bit longer. उससे आपको याद भी हो जाएगा.
Done, sir.
Done? All of you done? Is there anyone who is still writing? It seems no. Okay. Right, next. The benzyl alkyl ether. Now, in benzyl alkyl ether, we have structure like this. Now, Benz group is this carbon atom, okay, and then benzyl alkyl ether. So after CH2, we'll have oxygen, and then we'll have some R group. This R can be CH3, C2H5, anything. Okay. Now, when I react this with HI, okay. So what is going to happen? This bond is easier to break now. This red bond here. Why is this easier to break? Because as soon as we will break this, we will get a positive charge here. And this positive charge is resonance stabilized. That is why it is going to be easier. And this reaction is also going to be SN1 with the formation of carbocation. Okay. So should I write the whole thing? Wait a second. Let me write the whole thing. So this is benzene ring. oxygen, and some R group. First of all, H plus will be there. This H plus will be attacked by oxygen atom. Oxygen and then R group here. This oxygen also has hydrogen and a positive charge. This positive charge will break like this. And you will get CH2 positive. This CH2 positive is resonance stabilized. And then plus what we are getting? Plus we are getting ROH from here, right? Alcohol. And then further, this will be attacked by iodine negative. And we will get benzyl iodide. You write here. As cleavage of CO bond of benzyl group leads to resonance stabilized carbocation. This reaction occurs via SN1 and forms benzyl iodide and alcohol. Then all of you please tell me. लिख के बताइए, ठीक है? जैन आपको आ रहा है? ये सर नो जैन?
यस सर।
आपको समझ में आ रहा है?
हाँ सर, थोड़ा थोड़ा आ रहा
है ना? ऐसे कोशिश करते रहिए, आपको आते रहेगा, ठीक है? फिर उसके बाद जब नेक्स्ट चैप्टर स्टार्ट होगा वो तो स्टार्टिंग से ही पढ़ाएंगे तो सब समझ में आएगा, लेकिन आपको थोड़ा मेहनत ज्यादा करना पड़ेगा, है ना? आप थोड़ा लेट हो गए और आपने छुट्टियों में भी नहीं ज्वाइन किया। छुट्टियों में ज्वाइन करते तो फिर आपको उतना दिक्कत नहीं होता। अभी स्कूल भी है, थोड़ा मैनेज करना पड़ेगा आपको, ठीक है? रिकॉर्डिंग्स देखने पड़ेंगे, फिर उसके बाद आपको बताना पड़ेगा हमें, लाइक इफ यू नीड एनी एक्स्ट्रा क्लासेस ना, तो फिर हम जैसे मान लीजिए आपने रिकॉर्डिंग देखा, आपको समझ में नहीं आया, देन यू विल आस्क मी दैट सर कैन यू प्लीज हैव सम एक्स्ट्रा क्लास, ठीक है? और रिकॉर्डिंग भी हम इसी वजह से बोल रहे हैं क्योंकि अगर आपको हम एक्स्ट्रा क्लास देने लगे ना, इट विल टेक अ लॉट ऑफ टाइम, क्योंकि दोनों का टाइम आप फ्री है नहीं है सब देखना पड़ता है। रिकॉर्डिंग में आपके पास आसानी होगी, you can watch it at any time and you can also watch it at, let us say for example 1.5x speed. You can skip some parts where I'm just talking like right now, है ना? और उसके बाद वीक में एक दिन, फ्राइडे के दिन या फिर संडे के दिन हम आपको क्लास ले लेंगे अगर आपके पास कोई डाउट्स वगैरह होगा, ठीक है? जो भी चैप्टर आपका मिस हुआ है उन सब का फिर टेस्ट भी होगा आपके लिए अलग से, ताकि ये पता चले कि आपको आया कि नहीं आया, ठीक है? डन गाइस, ये था ना? प्लीज टेल मी।
Done, sir.
Done, sir.
Okay. Zan, where are you from originally?
सर।
Where are you from?
हैदराबाद।
Hyderabad. Okay. No, benzene alkyl is done. Then you will write next E part, that is diaryl ether. Okay, so if we have diaryl ether, what is diaryl ether? So we have two benzene ring like this, connected through oxygen atom, and when we react this with HI, it is going to give me no reaction. because both of these bonds are partial double bond and both of them cannot be broken. Okay, you'll write next. As both CO bonds have partial double bond character, and double bond character, it cannot be broken. Furthermore, what we can write that since oxygen is attached to benzene ring on both sides, iodine negative cannot attack due to electronic repulsion. Iodine negative is also electronic, benzene is also electronic. So this iodine negative cannot attack here also. It can neither attack on this carbon atom. Okay, so both of the attacks are not possible. That is why this gives me no reaction.
Done, sir.
Okay. Right next, electrophilic aromatic substitution of ethers. I can scroll up for 1 second. Okay, right here, alkoxy group अरे आप लोग प्लीज माइक ऑन करके बोल दिया कीजिए ना, नहीं तो चैट में लिखते का टाइम लग जाता है. Those who are done, they will write alkoxy group is an activating group which increases electron density at ortho and para positions. Making it ortho para directing group. Making it ortho para directing group. Let me know when you're done, guys. Done. Okay. So see, we have alkoxy group. it has oxygen and then R group here. Okay. And this oxygen, it has lone pair electrons. And if we have a benzene ring like this, as we can see that the condition for resonance has been fulfilled. We have we have here A with a double bond, B and then single bond C with lone pair electrons. So this is a condition for resonance. And then what we can do, we can move the electrons like this. It will give me double bond oxygen with R, one positive charge, and this double bond will convert to negative. Then we'll have this double bond and this double bond as it is. Furthermore, we can say that another condition for resonance has been fulfilled, A double bond B, single bond C, and negative charge. Now here the electron movement will be like this. This negative charge will form a double bond, and this double bond will form a negative charge here, which will give me another structure like this. So here we will have the double bond O and R as it is with one positive charge, and this negative charge has formed a double bond here. This double bond has formed a negative charge here, and this double bond is as it is, nothing has happened here. Okay, so as you can see that already from these two structures that there is electron density is increasing in the ortho position and also in the para position. You can make further resonating structure on your own. Okay. Now, the resonance hybrid structure from all of these structures that we will get is this one. We'll have a benzene ring like this with oxygen and an R group. And this oxygen will have this as a partial double bond character, and all of these bonds will have partial double bond character. There will be electron density increase in the ortho position and in the para position. Okay, and that is why these are the position which is going to attack the electrophile. Please write this down. Done, guys. Yes, no, please tell me.
Done, sir.
Done. Okay. So we'll see all of those reactions in one go only. Okay. So we'll identify these things. So if you have, for say, let us example. Yes. So we have, and then we have OCS3. So this is anisole. Okay. So when we have a reaction with Br, that means we are doing halogenation. Br2, and this is done in the presence of CS3COH. Then we are going to form two products. The OCS3 as it is, Br will get substituted in the ortho position, plus the Br will get substituted in the para position. Okay, I hope you guys know that this is also para position. Okay, ortho and para position. We can also do Riddle-Craft alkylation reaction. So if we have CS3Cl, or any alkyl chloride, okay, any alkyl halide in the presence of anhydrous AlCl3. This is going to give me see OCS3, and here I'm writing CS3. I hope you can see that this is what ortho substituted methyl anisole. Plus we'll get a para substituted one also. The para substituted one will look something like this, OCS3 here, and here we have the CS3 group. Okay, similarly if you want to do acetylation, Friedel-Crafts acetylation, then we'll have CS3, C double bond O, Cl, and same anhydrous AlCl3, any hydrogen carrier. Okay, so what is going to happen? This is going to give me OCS3 will be as it is. The Cl will go away, and we will be getting carbon double bond O, and then a CS3 group here. Ortho substituted, we have this acetyl group, and then we have para substituted acetyl group, something like this. यहाँ भी कर सकते हैं इसको OCS3. we'll have
सर
carbon
फिर
atom.
सीएल कहाँ पर जाएगा?
कौन सा Cl? ये Cl,
यस सर, जी सर।
ये Cl चला जाएगा आपका HCl बन के. देखिए आपके पास जो बेंजीन रिंग होता है ना, उसमें हर कार्बन के पास एक हाइड्रोजन होता है, राइट?
यस
सो यहाँ पे जो आपके पास यहाँ पे जो हाइड्रोजन था उसके साथ वो Cl चला जाएगा. ओके, सो ऑल ऑफ दीज, बाय द वे देखिए आप हालोअल्केन हालोरीन वाला चैप्टर एक बार प्लीज देखिए जिन लोगों ने नहीं देखा है. दिस इज जस्ट शोइंग दैट यू हैव नॉट वॉच्ड दैट लेक्चर, बिकॉज अगर आपने वो लेक्चर देखा होता तो हमने ये सारी चीजें बहुत डिटेल में एक्सप्लेन की हैं. ठीक है, ये देखिए आप. Can you see this Friedel-Crafts acylation? The introduction of acyl group in benzene ring in the presence of suitable acylating reagent. Okay, so यहाँ पे हमने एक एक चीज बताया. Formation of the electrophile. Then what do we have? We have the attack also, right? So each and every part I have told here. ठीक है, प्लीज इसको एक बार देख लीजिए इस चैप्टर को, those who have not done. Okay, you will write next nitration. So you have concentrated HNO3 in the presence of concentrated H2SO4. So here nitro group will be added. Okay, so the first one was halogenation. This was Friedel-Crafts alkylation. We have added alkyl group. This was Friedel-Crafts acylation, and this was nitration. ठीक है, अब जिन लोगों को समझ में नहीं आता है ना, एंड दोज हु कैन नॉट रिमेंबर इट, मेन प्रॉब्लम कि याद नहीं रहता लोगों को क्या हो रहा है, तो उनसे गुजारिश है कि वो लोग प्लीज लिख लिख के प्रैक्टिस करें, ठीक है। Just watching the lecture and attending the class is not going to help you guys once everything is done. Like for example, right now you will understand many points from here, है ना, कि आपके पास यहाँ पे डबल बॉन्ड कैरेक्टर आ रहा है, बट अनलेस until you do the same reactions at home, आप यहाँ पे लिख के प्रैक्टिस नहीं कीजिएगा तो फिर से आप भूल जाइएगा। And in all of them, the para substitute will be major, because we know that if you look at the ortho substitution here, this particular position, that is ortho position, it is a bit sterically hindered. That is why para position is more free, and in para position we will get the major of the products. So you can write major product will always be the para product. After this, you will write important note. Sulfonation of anisole is not possible, as the presence of H2SO4 makes the ethereal carbon protonated and positively charged. Which makes the benzene ring deactivating and not suitable for attacking electrophile. We have here OCS3 plus concentrated H2SO4. So from H2SO4 we'll get many H plus ions, and those H plus ions will be abstracted by the lone pair of oxygen atom. So it is going to give you oxygen CS3 with a hydrogen atom and a positive charge. And once this oxygen gets positive charge, it is going to be pulling electrons of the benzene ring. And if this pulling electrons from the benzene ring is getting electron deficient. And if it is electron deficient, it cannot attack the electrophile. It itself is getting electrophilic. So further no reaction. What can happen is that this particular some of the bonds can break here, but there will be no sulfonation. Then everyone is going to please tell me, guys.
Yes, done.
Done, sir.
Done. Okay. Okay, so that's it in ethers. Nothing more is there. In the next class, we will start with electrochemistry. Okay, we'll start with electrochemistry in the next class. I hope everyone is fine with electrochemistry, right? Yes or no? Please tell me. If anyone has any objection regarding electrochemistry, please tell me now. No one.
No, sir.
No. Electrochemistry is going to be fine. Okay. Okay. So we'll meet in the next class with electrochemistry. Okay. Second. Zan, you will stay. Others, you please leave.
Thank you, sir.
Thank you. Bye bye. Take care, guys.
सर वो -i + m -m उसका वीडियो भेज देंगे.
हम हमको भेजते हैं 1 सेकंड. I will send it to you. I'm just sending. Okay, sir.
जी सर,
On your
शुक्रिया.
WhatsApp. Yes, Adriel, Fahad, Huzaifa.
Sir, do you have last week's exams like the
Adriel, are you saying
answers yet?
something? I can't hear you.
Hello?
Hello?
Can you hear
Yes,
me?
Adriel.
Is it okay now?
A second. Yes, Adriel, tell me.
Sir, can you hear me?
I can hear you now. Tell me.
Okay. Sir, no, for the last week's exam, do you have the answers yet?
You want the answers for last week
Sir,
exam?
yeah, I was confused about the
बताइए.
second conversions.
Second conversion.
The third question.
Do you? Okay. Do you have the paper right now?
No, sir. You screen share.
No. Also take it. Let me screen share. Wait a second. Oh my God, these are. Adriel, आपने कोशिश की इसको कहीं और से देखने की? Like in the notebook itself?
What is it?
Did you try to see these questions from the notebook itself? These are from your notebook only. Should I show this?
The second one I don't understand.
Second one? Okay, fine. Tell me. Which chapter is this? Alcohol, right?
Yes.
Can we make alcohol from ethyl chloride? Yes or no?
Yes.
Can we make? Right, okay. Can we make aldehyde from alcohol? Can we make aldehyde from alcohol? Yes or no?
No, sir, I knew it, but then I got confused at the end.
Arey, how can I help you now? Tell me. I can show you the reaction, but I want you to think. And what will be the reagent here? Tell me. Ethyl chloride के लिए. If you want to convert ethyl chloride to, let us say, for example, ethanol, right? And then ethanol can be converted to ethanol also. Tell me what is the reagent you are going to use? Aqueous KOH, right? याद होना चाहिए अब.
Yes.
ठीक है? Then from alcohol to ethanol, what do we do for oxidation of alcohols? Tell me. Which reagent? If you want to stop at aldehyde.
PCC.
Correct. Very good. Bas.
Okay.
Nothing else.
Okay.
ओके
Okay, okay.
चलिए, यस हुजैफा, टेल मी, यू ट्राइंग टू सी समथिंग? नो, ओके फाइन, ठीक, हाँ हाँ, यू ऑल कैन लीव, यू ऑल कैन, ओनली जैन विल बी स्टेइंग, आई वांट टू टॉक टू जैन।
Thank you.
जैन, कैन यू हियर मी?
यस सर।
हाँ, ओके फाइन। अब ये बताइए, आपका 11th स्टैंडर्ड में आपका केमिस्ट्री कैसा था?
मेरा आधा वाला ईयर फिर अच्छा चला गया, पर इस साल आप अच्छा गया।
इस साल ठीक है आपका एग्जाम?
11th तक से था, 12th का ओके था, बस ऑर्गेनिक में थोड़ा हेल्प होना था।
ऑर्गेनिक केमिस्ट्री में?
हाँ, वो याद कर सकते चीज, पर बस अपने आप से या तो कुछ दूसरा क्वेश्चन आया तो वो नहीं कर सकते, तो इसलिए मैं क्लासेस से होना था, वो
अच्छा
रिकॉर्डेड
अच्छा
नोट्स हैं तो।
अच्छा अच्छा, ठीक है, हम समझ गए। देखिए, तो ऑर्गेनिक केमिस्ट्री में अगर आपको, इफ यू वांट टू बी गुड इन ऑर्गेनिक केमिस्ट्री, तो यू नो, आइडेंटिफाई दिस टाइप ऑफ स्ट्रक्चर, इसको क्या बोलते हैं?
क्या वो हेड ऑफ रिवॉर्ड।
बॉन्ड लाइन स्ट्रक्चर। ऐसे स्ट्रक्चर को क्या बोलते हैं? बॉन्ड लाइन स्ट्रक्चर, राइट? है ना? जिसमें हम
मेरे
या
को
तो इस पर
मेरे को ये सब
हम्म,
कुछ मालूम, बॉन्ड लाइन स्ट्रक्चर,
अच्छा
मतलब
ठीक है,
बेसिक
ठीक,
चीजें मेरे को मालूम, इतना इतना गंदा भी नहीं है
अच्छा अच्छा,
केमिस्ट्री,
देखिए देखिए
पर
देखिए, एक
बस मेरे
सेकंड,
को। हाँ,
हाँ एक सेकंड, देखिए, कैन यू टेल मी हाउ मेनी हाइड्रोजन दिस कार्बन हैज? अच्छा, इसमें कितने कार्बन है, यही बता दीजिए आप सबसे पहले, ये जो हमने बनाया इसमें कितने कार्बन है?
तो एक, तीन, एक, दो, पांच कार्बन, नहीं एक मिनट, कार्बन नहीं, दो 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 कार्बन। हाँ,
2 कार्बन है। अच्छा, यहाँ पे
ये
कितने
तो
हाइड्रोजन
दिखता
होंगे?
है, यहाँ पर दो
यहाँ
होंगे
पे,
क्योंकि यहाँ दो होंगे।
यहाँ पे 2 हाइड्रोजन, यहाँ पे कितने हाइड्रोजन होंगे?
तीन,
3 हाइड्रोजन होंगे, ठीक है।
C2H5 होंगे।
यहाँ पे कितने हाइड्रोजन होंगे?
तो यहाँ पर इसमें इसमें जो आप डॉट प्रेस हो या होल स्ट्रक्चर।
यहाँ पे बस जो हमने व्हाइट डॉट दिया है।
हाँ, यहाँ पर कार्बन एक है, पर हाइड्रोजन आई थिंक एक है खाली।
एक है, ठीक है, चलिए, ठीक है, तो आपका ये, ठीक है। अच्छा, आप जो स्ट्रक्चर्स बनाते हैं वो इसी तरह बनाते हैं या फिर आप कैसे बनाते
इसी तरह बनाते हैं, मतलब कोई
हैं? इसी
वो
तरह
नहीं, और
बनाते हैं
सर्कल
बॉन्ड?
बीच में।
नहीं
जी,
नहीं नहीं नहीं,
सर्कल बीच
देखिए,
में।
नहीं नहीं नहीं, हम वो इस वजह से पूछ बोल रहे हैं ना, क्योंकि देखिए, अगर हम इसी स्ट्रक्चर को बनाते हैं, CH3CH2OH, ठीक है, इतना टाइम लगा हमें, और अगर हम इसको ऐसे बना देंगे तो ये तुरंत बन जाएगा। अच्छा, जल्दी बनाने से क्या होगा, ज्यादा ज्यादा प्रैक्टिस हो पाएगी, ठीक है। तो दैट इज व्हाई आई मेक श्योर दैट ईच एंड एवरी वन ऑफ माय स्टूडेंट दे नो दिस बॉन्ड लाइन स्ट्रक्चर, दे नो हाउ मेनी कार्बन्स आर देयर एंड ईच कार्बन इज हैविंग हाउ मेनी हाइड्रोजन, तो ये आपको आता है, चलिए, बहुत अच्छी बात है। नाउ आई थिंक, अगर हम बोले आपको इंडक्टिव इफेक्ट, ये आप बताइए, आप समझ पा रहे हैं क्या बोलना चाह रहे हैं? प्लस आई,
माइनस
माइनस
आएगा।
आई, ये ग्रुप्स याद हैं आपको? ग्रुप्स पता है? प्लस एम कैसे पहचानते हैं, माइनस एम कैसे
वो
पहचानते हैं?
इंडक्टिव इफेक्ट याद नहीं, रेजोनेंस थोड़ा मालूम, पर इंडक्टिव इफेक्ट नहीं।
मेसोमेरिक इफेक्ट, जैसे अगर हम आपसे कहें ये वाला ग्रुप हो, ओ एच ग्रुप है, तो प्लस एम होगा या माइनस एम होगा? सिमिलरली अगर हम आपसे पूछें, आपके पास है सी डबल बॉन्ड ओ एंड देन यू हैव हाइड्रोजन, CHO ग्रुप है आपके पास, तो प्लस एम होगा या माइनस एम होगा, ऐसे आप आइडेंटिफाई कर पाते हैं?
नहीं,
नहीं, अभी नहीं, चलिए ठीक है,
ये
इसमें कोई दिक्कत नहीं।
चैप्टर 11 केमिकल बॉन्ड नहीं है ना ये।
नहीं नहीं, केमिकल बॉन्डिंग नहीं है, ये है 11th स्टैंडर्ड का ऑर्गेनिक केमिस्ट्री, सम बेसिक कंसेप्ट।
अच्छा।
ओके, ठीक है। अच्छा, IUPAC नॉमेनक्लेचर आपका कैसा है?
अ, अच्छा, मेरे को आई थिंक अच्छा है, डिपेंड स्ट्रक्चर कैसा है, अगर समझ आया तो समझ आया, नहीं तो नहीं, तो वो कॉम्प्लेक्स वाले है
ऐसा
नहीं
कुछ, ऐसे कुछ पक्का नहीं है आपका, मतलब
नहीं, मेरे को आता, अगर आप देखे तो समझ में आता थोड़ा थोड़ा।
इसको बताइए क्या होगा इसका नाम?
एक मिनट।
हाँ ठीक है, आप टाइम ले दीजिए अपना।
3 ethyl and then butanol with a single bond with double bond नहीं है. ये 1 2 3 4 5 कार्बन चेन ये वाला है OH मतलब कहाँ से भी तो
ठीक।
OH एंड होता तो 1 2 3 4 कार्बन है एंड पोजीशन मतलब पोजीशन ये कहाँ से इससे
Numbering।
स्टार्ट करना ना OH से नंबरिंग हाँ
हाँ
तो 1 2 3 4 तो 2 हाँ 2 एंड देन इथाइल क्योंकि 2 यहाँ है ना कार्बन
ठीक है ठीक है ठीक है, हम
2
समझ गए, सही है
इथाइल
आपका।
दैट्स
ब्यूटेनॉल।
ब्यूटेनॉल उसको डबल बॉन्ड
ब्यूटेनॉल, ठीक है, हाँ ठीक है। तो मेनली आई थिंक आपको जो प्रॉब्लम है थोड़ी बहुत वो इन सब में है ना? ठीक है।
हाँ इंडक्टिव रेजिस्टेंस ये वो
तो सबसे पहले आप ये काम कीजिए कि हमने आपको ना एक प्लेलिस्ट शेयर किया है, उसमें सबसे पहला जो प्लेलिस्ट है हमने लिखा यू कैन वॉच द प्रीवियस क्लास रिकॉर्डिंग फ्रॉम हियर, दैट इज 12th स्टैंडर्ड का। ठीक है, आप व्हाट्सएप में देखिए जरा।
हाँ मैं देखा
आपने
मैं देखा
देखा आपने? नहीं नहीं, उसको ओपन कीजिए प्लेलिस्ट को। आप मोबाइल से ही कनेक्टेड है क्या?
नहीं मैं दूसरे से हूँ
हाँ ठीक है ठीक है,
मेरे को हाँ,
तो आप फोन में देखिए। ठीक है, तो फोन में जब आप देखिएगा तो यू विल सी दैट आई हैव आल्सो टॉट देयर सम क्लासेस ऑन सॉलिड स्टेट, लेकिन सॉलिड स्टेट तो आ नहीं रहा है आप लोग का। ठीक है, तो फिर उसके
जी
बाद आप स्टार्ट कीजिएगा कंसंट्रेशन टर्म जो सोल्यूशन का चैप्टर है, आप या तो वहां से
पहले
स्टार्ट कीजिए।
पहले मैं क्या बोलते हैं ये
ऑर्गेनिक
सोल्यूशन
ऑर्गेनिक करना
स्टार्ट कर
है।
लो
नहीं नहीं
ये
नहीं
क्या
नहीं,
सोल्यूशन
अगर आपका सोल्यूशन ठीक है तो
हाँ
स्टार्ट
मैं
करने की जरूरत
सोल्यूशन
नहीं
ठीक
है।
है खाली वो अब नॉर्मल मोलर मास देखना है पर उसका था क्वेश्चन ठीक है मेरे सोल्यूशन
ठीक है, हाँ
खाली
ठीक है। तो
हाँ
ऑस्मोटिक प्रेशर और एबनॉर्मल मोलर मास, जो ये सारी चीजें हैं, कॉलिगेटिव प्रॉपर्टीज एंड एबनॉर्मल मोलर मास, हम बोलेंगे दोनों ही देख लीजिए। अगर आपको थोड़ा सा डिफिकल्टी होगा कहीं कॉलिगेटिव प्रॉपर्टी में तो वो भी ठीक हो जाएगा। ठीक है, एबनॉर्मल मोलर मास वाला देख लीजिएगा। एंड देन उसके बाद हैलोअल्किन हैलोरीन हमने स्टार्ट किया। ठीक है, आप स्टार्ट कीजिए हैलोअल्किन हैलोरीन से। ओके,
जी
आई एम ऑल्सो सेंडिंग यू द लेक्चर